I'm going to go ahead and switch over to Deb Sheeler, who will be presenting the next talk. Okay, so okay, I'm at the hyperspectral imagery.
Yeah, so
okay.
One of the technologies, the additional technologies that we've been looking into is also is kind of incorporating the smartphone application. And working with the Galileo group here, smartphones have been like the technological hallmark over the last decade. And so where we see a value here is that being able to capture imagery, process that in the cloud, and be able to return the results of that near real time. So essentially, you can see here where the smartphone application is more of a low-cost, off-the-shelf commercial technology that a majority of the rest of the world is essentially utilizing, right? And so in comparison to the traditional expensive satellite imagery that's being captured and not on a regular basis or quick enough turnaround time versus the aircraft application where you have to deploy a plane up in the air, determine, you know, weather-wise, cloud issues. The drone application is the next tier where it's more of a cost, less of a cost prohibitive option, and allows the different sensors that we have nowadays to be able to be applied to that. So combining both the boots on the ground application utilizing the phone app to capture high resolution imagery as well as multispectral imagery will allow us to be able to really take advantage of a less cost sensor hardware. Go ahead and move to the next slide, Justin. So on the second slide here, you'll see that it's an example that how the application would be applied. So the hyperspectral imagery application that Galileo has built utilizes the phones to actually capture it, push the data up into the clouds into a library that has the spectral characteristics, and then be able to, in near real time, provide back is the vision of this new technology that we're trying to help them pilot. So ultimately, you know, with the smartphone capability in the hands of anybody, especially our own teams out in the field, this is an application that we feel may be of value and have chosen that as one of the small bets. So on the next slide here, you'll see that we're currently completing a multi-state EAB project to identify specific genus types for ash, oaks, maples, other broadleaf, and conifers. And we are doing this on a multi-state project in Alabama, Mississippi, which identifies the 6 cities there. The information has actually been captured with the traditional methods, which is the fixed wing aircraft deployed up in it, and it's because of the fact that the coverage is much larger than a drone would be able to capture in the time frame that's allotted. So currently within this past 6 weeks here, we've acquired this imagery, and there's a couple examples there of the results of the acquisition in multispectral, hyperspectral imagery. And in the end, they're currently processing the image with the LiDAR, and we'll be able to provide the client with not only possible locations of ash as well as oaks, maples, other broadleaf, and conifers, but also be able to provide a 3D rendering of a video of the areas of those possible locations. So what's in process is the processing currently right now, and what is going to be provided to the client is the canopy assessment, species identification, and the reporting and video of that. Part of this, we were able to incorporate the pilot of the smartphone application to be able to locate specific species, capture the location of those, and then we're going to compare the results of our normal ground-based survey, and then be able to build that library, so that in the hopes that in the end we'll be able to apply this in that cloud-based application where we can be able to provide an image and then be able to get back the results in near real time. So for the Armada application, for the next, as part of this pilot project, we're utilizing that in the field for the collection process on sampling of the species at each of the locations, so that in the end, the overall spectral characteristics will be pulled from the imagery that was captured via the aircraft. What we want to look at going forward is another pilot where we can utilize this application with another technology that they've also built, where it's Armada swarm mode, TM mode, or swarm mode, which allows us to utilize a tiered 3 phones stacked, as you can see here in the picture, together and mounted on a drone, so that you can get more coverage and ground coverage versus boots on the ground personnel collecting the information and the imagery. So hopefully then we'll be able to fly over specific locations and be able to return conditions of vegetation, of poor vegetation or stressed vegetation, to be able to identify what type of issues may be occurring, whether it's pest or other drought issues. With the capability of the low and slow flying drones, you can cover more ground versus the boots on the ground. And so we're looking right now at some possible pilots to compare the results of the smartphone application as on a drone platform. Okay.
Thanks, Deb. And we did have a question come up during your presentation. How does the smartphone application work?
It has filters that are built into the application, and so it identifies different bands of this, and it fine-tunes the specific bands to be able to identify the near infrared as part of the spectral characteristics of the imagery that it's and the picture that's being taken. So it utilizes the different bands within that that's already built into the application that they've built.
All right, great. Thank you, Deb. All right.